students, in this class we will go to the new topic called regression analysis. The class objectives of this lecture is we will study simple linear regression model. When we say simple linear regression model, only one independent variable will be considered. Then we will see what is the least square method, that is the principle behind this regression model. Then we will see what is coefficient of determination. A goodness of a regression model is explained generally with the help of this coefficient of determination called R square. We will see in detail later. Then what are the model assumptions? Then we can test for significance. Even hypothesis testing also can be done with the help of our regression analysis. Then using the estimated regression equation for estimation, and we will use a prediction also. Many problems in engineering and science involve exploring the relationship between two or more variables. So far what we have seen, the same variable we have compared with we have taken some sample, with the help of sample we have predicted the population parameter, that is the same variable. Sometime we have compared the mean, sometime we have compared the variance, but this lecture we are going to take two different variables. Regression analysis is a statistical technique that is very useful for these type of problems where the cause and effect has to be measured. This model can also be used for process optimization, such as finding the level of temperature that maximize the yield or process control purpose. If there are many independent variable, we can say which independent variable is more important variable that affect our dependent variable. We will see one example. There is the table is given, there is an x variable called hydrocarbon level, y variable is called purity. As an illustration, consider the data in the table. In this table, y is the purity of oxygen produced in a chemical distillation process, and x is percentage of hydrocarbons that are present in the main condenser of the distillation unit. Now we are going to see what is the influence of x on purity of oxygen. So I have entered this data in Excel. So I have saved, the file name is reg2.xlsx. When I import data equal to pd.read_excel, I have specified the path. So x equal to data, that is the hydrocarbon level, that column is my x variable, y equal to in data file 02, that is my dependent variable. When I use plot.figure, then SNS dot regression plot, reg plot x comma y fit underscore regression equal to true. Then when I use this plt dot scatter np dot mean x comma np dot mean y comma color equal to green. So what I am saying, I am getting a scatter plot between hydrocarbon level and the oxygen. So what is happening, whenever the hydrocarbon level is increasing, the oxygen level also increasing. There is a positive relationship. Suppose if I want to make a relation between, quantify the magnitude of x and how it is influencing on y, then I should go for regression equation. That we will do in coming slides. Now we will go to the theory behind the simple linear regression model. The equation that describes how y is related to x and an error term is called regression model. The simple linear regression model is y equal to beta 0 plus beta 1 x plus error term. Here y equal to beta 0 plus beta 1 x plus error term, where beta 0 and beta 1 are called the parameter of the model, epsilon is the random variable called the error term. So what we are going to do, we are going to estimate the value of y with the help of independent variable x. Because x itself will not enough to predict the y variable, there may be some unknown variable other than x. The error due to that unknown variable, the otherwise unexplained variance, we are going to call it as error term. The simple linear regression equation is expectation of y equal to beta 0 plus beta 1 x. When you compare in the previous slide, there was an error term, here there is no error term, because while calculating the value of beta 1, we have taken care that error is minimized. Not only that, in the previous slide we are writing y, now it is expected value of y. So what we are predicting is the mean value of y, not the actual value of y, where the graph of the regression equation is a straight line. because the power of x is 1. Beta 0 is the y-intercept of the regression line, beta 1 is the slope of the regression line. So, expected y is the expected value of y for a given x value. Expected value is nothing but mean value. A simple linear regression equations, this is an example of positive linear relationship. You see in x axis there is a whenever the value of x is increasing, the expected value of y also increasing. So, the slope beta 1 of this b1 is a positive. The intercept, so this distance is your b0. This is an example of negative linear relationship. What is happening when x increases, the expected value of y is decreasing. Here the slope is negative. Here there is no relationship because it is a line which is parallel to x axis. So, here the slope is 0. So, what is the meaning of this? Irrespective of any value of x, the expected value of y is same. So, here we can say the value of x and y are independent. The estimated simple linear regression equation is y hat equal to b0 plus b1x. Generally, if I write capital Y, if I write beta 0 plus beta 1x, so if I use capital letters, that is for the population. So, whatever I write in small letter, that is for the sample. So, y hat is the estimated regression line, b0 is the y-intercept of the line, b1 is the slope of the line, y hat is the estimated value of y for given x value. The principle behind the least square method is the sum of the square of the error has to be minimized. Suppose I have some x value x, y, I have some number for x, I have a number for y. Suppose I have drawn this way. So, this is x axis, this is y axis, I have plotted line like this. So, my objective here is I have to draw a line, ideally that line has to pass through all the given points, but that is not possible. So, what I am going to do? I am going to draw a line so that the error is minimized. Not only error, so for example, this is E1. So, if you say this is E2, this is like that, there will be many E3. So, this is positive error, actual minus predicted value. So, this line is y hat equal to, so B0 plus B1x. So, now what is happening? So, this much distance is, it is a vertical line. So, this much distance is my error, actual minus predicted value. This vertical line distance is E2. So, what is happening? This is error. So, what you have to do? The error square and sum of the error square has to be minimized like this, 3 like this. So, sum of the error has to be minimized. I have to draw a line such a way that sum of the square of the error has to be minimized. I can draw different lines. Suppose I can draw this way also, this way also. For each line, I have to find out this sum of the square of the error. Wherever the sum of the square of the error is minimum, so that line is the best line. That principle called least square method. Why we are squaring? There is a logic behind this. If you are not squaring, the positive error and negative error will become nullified, then you will get a 0. That is why we are squaring that. The same logic, for example, the formula for variance, what we are doing, sigma of x minus x bar whole square n minus 1. The logic here, why we are squaring? There are two purposes, otherwise sigma of x minus x bar equal to 0. Here the sum of positive error plus negative error becomes 0. The square transformation says one more implications, that suppose the deviation is less, for example it is a 0.5, when you square it the net is 0.25. Suppose the deviation is 5, the net value is 55. So, what is happening? There is a lesser deviation, there is a lesser penalty. There is a larger deviation, larger penalty. That is the beauty of this squared transformation. In the estimation process, what is happening? Initially we will assume a regression model y equal to beta 0 plus beta 1 x plus e. That regression model we will predict with the help of regression equation, that is expected value of y equal to beta 0 plus beta 1 x. You see that in the regression equation there is no error term. Here the unknown parameters are the population regression model, say y equal to beta 0 plus beta 1 x plus e. The regression equation is expected value of y equal to beta 0 plus beta 1 x. Here the unknown parameters are beta 0 and beta 1. So we have to estimate the value of beta 0 and beta 1, more importantly the value of beta 1. What you are going to estimate it, whether the value of beta 1 is 0 or other than 0. If I estimate beta 1 equal to 0, that means there is no relation between x and y. So this is our assumed equation. From that, what I am going to do, I am going to collect the sample for my x variable and y variable. Here x is independent variable, y is dependent variable. So with the help of the sample data, I am going to make a regression equation that is applicable only for the sample. So y hat equal to b0 plus beta 1 x. So here b0, b1 is the sample statistics. So this equation is valid only for the sample. Now I am going to estimate that whether the value of beta 1 and beta 0 is valid even for the population level also. What will happen? What is the meaning of that one is, sometime this y equal to b0 plus beta 1 x, with the help of sample you can construct a regression equation. But when you predict it, when you estimate value of b1, when you estimate value of beta 0, that may not be significant at the population level. So that time, so what we are going to say, the beta 1 is equal to 0. If I say if the beta 1 is equal to 0, there is no relation between x and y. That we will see in the coming slides. So how this regression is different from our previous concept which we have studied. For example, what have happened, with the help of x bar we have predicted population parameter mean. So with the help of sample variance we have predicted the population variance. With the help of sample proportion we have predicted the population proportion. The regression, actually what is happening, there is a sample, smaller circle is sample, bigger circle is population. I have some x and y value from the sample. With the help of x and y value, I have predicted a regression equation y equal to b0 beta 1 x. Now I am going to prove that whether this relationship is valid even for the population or not. So what I am going to do, capital Y equal to beta 0 plus beta 1 x. So with the help of regression equation, that means a sample model, I am going to predict whether this model or this relationship is valid for even for the population or not. Sometime what will happen, you can construct a regression equation with the help of sample data. You can say there is a relation between x and y, but when you go to the population level, there may not be relation between x and y. So what is the difference between this regression modeling and the previous our hypothesis testing? In hypothesis testing, we have tested only one parameter at a time. What we have done? We have tested, we have predicted mean or variance or population proportion. Now I have constructed a model, small model with the help of sample data. I am testing this model in the population level. Okay. Here I am simultaneously I am checking 2-3 parameters. One is my beta 1 is one parameter, beta 0 is another parameter. Okay. Like that we may have different, this is a simple regression, like that in the multiple regression there may be different independent variable. This is the logic of regression modeling. Yeah, what will you do? Suppose in the regression equation with the help of sample data, what is required is I have to find out what is the value of beta 1, b1, this is called slope, this is my y intercept. Okay. So, what is happening? A line is like this. Suppose there are 2 points. Suppose I am going to call this is say x1 comma y1, this is x2 comma y2, like that there may be many points. For example, this is xn comma yn. Okay. So, this is my x axis, this is y axis. So, what I am going to do, this is my error. So, I am going to call it as E1, this is E2, this is En. So, what I am going to do, first I am going to find out the error for each values, then I am going to square the error, then I am going to sum the error, then for what value of this B1 and B0 the error will get minimized. So, that I am doing here in the next slide. So, what is happening? So, here I am going to call it as this is y equal to mx plus b. It is only our traditional notation, because in our schooling we have studied this way only, you can use any notations. So, here what is the error term? Actual minus predicted. So, my actual error is for this one, my actual point is y1, my predicted value is y. So, y1 minus y. So, y1 minus y is my mx1 plus b whole square. For second term, y2 is actual mx2 plus b, because you know this y equal to mx plus b. So, y equal to y1, when you substitute x equal to x1, you will get y predicted value. So, actual minus predicted, that is the square. So, I am finding this actual minus predicted is error, I am squaring the error. So, for the second term y2 minus mx2 plus b, and like this yn minus mxn plus b whole square. Just I am going to simplify this. It is nothing but your a minus b whole square formula, y1 square minus 2y1 mx1b plus mx1 plus b whole square. Similarly, for the pink one, y2 square a minus b whole square minus 2y2 mx2 plus b plus mx2 plus b whole square. For the nth term, yn square minus 2yn mxn plus b plus mxn plus b whole square. Just I am going to simplify this. So, when you simplify this, y1 square will be there, you take this minus 2y1 inside, so it will become minus 2 x1 y1 m, then minus 2 y1 b plus this is a plus b whole square, m square x1 square plus 2m x1 b plus b square. This was the first term. For the second term, y2 square minus 2x2 y2 m minus 2 y2 b plus m square x2 2 square plus 2m x2 b plus b square. For the nth term, yn square is nothing but sometime a minus b, sometime a plus b whole square formula. Yn square minus 2 xn yn m minus 2 yn b plus m square xn square plus 2m xn b plus b square. Now, what I am going to do the next term, I am going to add all this y1 square plus y2 square yn square. Then here the minus 2m is the constant here, the next second term. So, I am going to add this, I am going to group it. Similarly, here minus 2b is same. So, I am going to add only y1 plus y2 plus up to yn. Here the m square is the constant. So, x1 square plus x2 square up to x1 square. Here 2mb is a constant. So, I am going to add x1 plus x2 up to xn. So, here there are p square b square. If I add n time, there will be nb square. That is what I have done this one. So, I have grouped all y1 square term, y1 square plus y2 square plus yn square minus 2m. As I told you previously, I am going to here see minus 2m is constant. So, x1 y1 plus x2 y2 plus up to xn y1. If I go back, so here minus 2b for the third term, minus 2b is the constant, minus 2b, the remaining is y1 plus y2 up to yn. The fourth term, see m square is a constant, m square, x1 square, x2 square plus up to xn square. The next one, see 2mb, the 2mb is constant in all the terms. So when you bring it common, 2mb, the remaining is x1 plus x2 plus xn. The last term is b square, b square, b square. So here what I am going to do, you see that if I want to know y1 square mean, so what I am going to do, sigma of y1 square plus y2 square up to yn square divided by n. So what I am going to do, the summation I am going to write in terms of its average. So when I take this one, so instead of y1 square plus y2 square, I can write n y1 square. Similarly, this minus 2m, so this one I can write n x x1 y1 bar. Here minus 2b, what I have done, I have grouped the square term. So the first term is y1 square plus y2 square plus and so on plus yn square. So this I am going to write in terms of its average value. So I am going to write y square bar is nothing but y1 square plus y2 square plus y3 square up to yn square divided by n. So now what is happening, this y1 square, y2 square and yn square can be replaced by n multiplied by y square bar. So that is why I wrote it n y square bar. Similarly, the second term x1 y1, x2 y2 plus up to xn y1 can be written as xy bar multiplied by n. So the remaining term is 2m. So 2m and xy bar. The next one is minus 2b, that I am going to write n y bar. Similarly, the third term, the m square will come as it is. So x1 square plus x2 square and so on, I am going to write in terms of n multiplied by x square bar. The next term is 2mb, I am going to write n x bar. There are nb squares, so I am writing nb square. So this is the simplified of the error term. So actually it is a squared error. So what is happening, ny square minus ny square minus 2mn xy bar minus 2bny bar plus m square n x square bar plus 2m bn x bar nb square. Now what is happening here, which is variable? There are two variable. One is here m is the slope. The slope is the variable. Because why I am saying slope is variable, I can draw for different slope for different line. The slope is variable. So I have to find out for what value of this slope the square of the error will be minimized. So it is, we say it is a maximum minima principle. So what we will do, for generally what we will do for maximum minima principle, dy by dx equal to 0, you might have studied in schooling. So d square y by dx square is negative less than 0. So that is the, so it is this way, So what is happening, dy by dx equal to 0 is this point. If it is negative, that means it is a maximum point. If it is a positive, so that is in the minimum point. So what is happening, even though for both the conditions, the first one is dy by dx equal to 0. Here x is a variable. For example, here the m, the slope is variable and the b, y intercept is the variable. So first we will, because there are two variables there, we partially differentiate this squared error first with respect to m. When you partially differentiate with respect to m, so there is no n term, there will be minus 2n xy bar plus, here also there is no m term, so 0, so 2m n x square bar, here there is m term 2b n x bar, this will become 0, then equate it to 0. So when you simplify this, 2n is the constant, no? 2n, here 2n, 2n. So remove this, the remaining is minus xy bar plus m x square bar plus bx. So I am going to write in this one y equal to mxb plus format. So what will happen, mx square plus bx, I have taken right hand side xy bar. So I am going to divide by x bar. So x square bar by x bar plus b, this is xy bar minus xy bar divided by x bar. Now what is happening, this is mx plus b equal to y format. Which one? This equation. So m is m. So the x coordinate is x square bar divided by x bar. So the y coordinate is xy bar divided by x bar. So what this implies is, if we want to draw a best line, that line has to pass through this point. So this is x coordinate, this is first one is x coordinate, second one is coordinate. So if you want to draw a line which should minimize the sum of the squared error, that has to pass through this point. Then we will find out the another point, because to know the slope we need 2 points, we got already 1 point. So now we differentiate, partially differentiate with respect to b. So here there is no b term 0, here also there is no b term 0, here there is a b term. So minus 2 n y bar, there is no b term, here 2 m n x bar, so here 2 n b, so equated to 0. Here also this 2 n is a constant, 2 n 2 n. So divide both sides, the remaining is minus y bar plus mx bar plus b equal to 0. So when you simplify y equal to mx plus b format, so now this is y equal to mx plus b format. So this line passing through the y bar, so this line is passing through x bar. So the another point is x bar comma y bar. So you see there is a very important result. If you want to draw a best line, that line has to pass through the average value of its x and average value of y. One of the points should, that line has to pass through that, then only that line may be the best line. So we got the 2 points, one is x bar comma y bar, the another point is x square bar by x bar comma xy bar divided by x bar. So when we know this is one point, the another point is x bar comma y bar. So if you want to know the slope of this equations, generally what is the slope formula, y2 minus y1 divided by x2 minus x1. When you use that formula, you will get formula for slope. Dear students, we got the 2 point. After using the least square principle, the one point is x square bar divided by x bar comma xy bar divided by x bar. That is one point. Another point is x bar comma y bar. When there are 2 points there, we can find out the slope. What is the slope formula? This is first point, second point. What is the slope formula? Suppose traditionally we might have studied in the schooling. Suppose there are 2.1, say point 1 is x1 comma y1. So point 2 is x2 comma y2. Okay. So the x1 point is x square bar by x bar comma y1 point is xy bar divided by x bar. So x2 point is x bar, y2 point is y bar. We know the slope formula, y2 minus y1 divided by x2 minus x1. Here the y2 is y bar minus y1 is xy bar divided by x bar divided by x2 is x bar minus, actually this is, I wrote x1 y1 only our convenient, right. So this x1 is different. x2 is x bar comma x1 is x square bar by x bar. So this is when you multiply both the side numerator and denominator by x bar, it will become x bar y bar minus xy bar divided by x bar whole square x square bar, because x bar get cancelled. When you bring minus this one, when you multiply both sides with minus, it will become xy bar minus x bar y bar divided by x square bar minus x bar whole square. This is the formula for slope. Okay. Actually this slope is nothing but, when you look at the numerator, that is nothing but the covariance of x comma y. The denominator is variance of x. I will explain how this numerator is covariance. So we know that in our probability class we studied covariance of x comma y is expected value of x minus x bar into y minus y bar. When you simplify this, you bring this side xy minus xy bar minus x bar y plus x bar y bar. When you bring e inside, it will become e x y minus, because y bar is a number, when you bring e of x, again it is x bar, minus x bar is a number, when you bring e inside it will become y bar, because y bar is a number, so that will be as it is. So when you bring e here, it can be written as x y bar. So minus x bar y bar minus x bar y bar plus x bar y bar, you can cancel it, plus and minus, the remaining is x y bar minus x bar y bar. That is nothing but the numerator. I am going back, you see that x y bar minus x bar y bar is the numerator. So in the slope formula, numerator is nothing but covariance of x comma y. So the variance of x is, this also we studied from schooling. So x minus x bar whole square, you expand it, x square minus 2x x bar plus x bar square. When you bring x inside, this will become e of x square minus 2, x bar is a number, the expected value of a number is number itself, but e of x will become x bar, this is number itself, it will be keep as it is. So when you bring e inside, it will become x square bar. So there are minus 2 x bar whole square plus x bar whole square. So when you subtract it, the remaining is 1. So x square minus x bar whole square. And when I go back, you see, look at this formula, see, it is resembling with this denominator. So in the slope formula, the numerator is nothing but, right, numerator is nothing but the covariance, denominator nothing but the variance of x. Actually this variance, covariance, correlation coefficient, regression slope, all are having some relationship. See that the variance formula, we know sigma of x minus x bar whole square divided by n minus 1. But it is only one variable. In the covariant, there are two variables x comma y. So sigma of x minus x bar, even this can be written as sigma of x minus x bar into x minus x bar. There are two variables there. Instead of another x minus x bar, you can write sigma of x minus x bar into y minus y bar divided by n minus 1. So the correlation coefficient is nothing but when you divide this covariance divided by its own standard deviation, it will give correlation coefficient. So but the slope is the ratio of covariance divided by variance of x. You see the variance is, the covariance is this one, sigma of x minus x bar into y minus y bar divided by n minus 1, assuming that the equal same degrees of freedom. The denominator is sigma of x minus x bar whole square by n minus 1. So this n minus 1 is get cancelled. The formula for slope is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. That is how we got this formula B1. So you need not, it is easy way to remember this formula for the slope is nothing but covariance by variance. In this class we started about the regression analysis. I have explained the importance of regression, how the regression is different from our traditional hypothesis testing. In the regression equation, there is a y-intercept is there and slope is there. By using least square method, I have derived the formula for finding the slope and the y-intercept. The formula for slope is nothing but the covariance by variance. Then I have interlinked how variance, covariance, correlation coefficient and regression coefficients, all these are interrelated. The advantage here is you need not remember the formula. Formula is, if you know the variance formula and covariance formula, easily you can find out the slope of a regression equation. We will continue in the next class. By taking one example, I will explain how to use this regression equation for prediction purpose. Thank you very much.